Hi and Assalamualaikum. My name is Fatin Shazira, and in this video I will explain how to solve a question involving the joint probability distribution of two discrete random variables x and y. The question is divided into 5 parts from part A until E, and I will explain each part step by step using formulas. We are given the joint probability distribution function f of x, comma y equals c times x plus y, where x can be 0, 1 or 2 and y can be 1, 2 or 3. The probability is 0 elsewhere. Since x and y take discrete values, they are discrete random variables. To find the value of c, I use the probability rule that the sum of all joint probabilities must be equal to 1. Since x and y take a finite number of discrete values, I just represent this summation using a joint probability table. And each cell in the table represents the joint probability f of x, y. By adding all the probability f of x, y, I obtain 27c equals 1. Therefore, c equals 1 over 27. And then, after finding the value of c, I substitute c equals 1 over 27 into the joint probability distribution function. That is f of x, y equals 1 over 27 times x plus y. Using this formula, I construct the joint probability distribution table of x and y. Each cell in the table represents the joint probability for a specific value of x and y. When I add all probabilities in the table, the total is equal to 1, which confirms that the joint probability distribution is valid. For question B, they ask us to find the marginal distribution of x and y. To find them, I add the probabilities across y for marginal distribution of x. Probability of x equals 0 is 6 over 27. Probability of x equals 1 is 9 over 27. And probability of x equals 2 is 12 over 27. And to find the marginal distribution of y, I add the probabilities across x. Probability of y equals 1 is 6 over 27. Probability of y equals 2 is 9 over 27. And probability of y equals 3 is 12 over 27. Determine whether x and y are independent. To check whether x and y are independent, I use the independence condition. F of x, y equals probability of x equals x multiplied by probability of y equals y. I compare the joint probability with the product of the marginal probabilities for one pair of values. Since the two values are not equal, then x and y are not independent. Next, I find the probability that y is less than 3 given that x equals 2. I use the conditional probability formula, which is probability of A given B equals probability of A intersection B divided by probability of B. Here, y less than 3 means y equals 1 or 2. So, probability of y less than 3 given x equals 2 equals probability of y less than 3 and x equals 2 divided by probability of x equals 2. Substituting the values, I got 7 over 27 divided by 12 over 27. After simplifying, the answer is 7 over 12. For question E, variance and expectation, to calculate the variance of x, I use the formula variance of x equals expected value of x squared minus expected value of x squared. After calculation, the variance of x is 50 over 81. Similarly, the variance of y is also 50 over 81. Finally, to find the expected value of 4x squared plus 6y minus 2. I use the linearity of expectation. Expected value of 4x squared plus 6y minus 2 equals 4 times expected value of x squared plus 6 times expected value of y minus 2. After substitution and simplification, the final answer is 178 over 9.
Now we go to question number 2. Assalamualaikum. My name is Farhana Tasnim Binti Bahari and my student ID is 2024417998. We'll be presenting question 2. Given the question is about joint probability function density of x and y, which is that fxy equals to 1 over 3 3x squared plus xy with the limit x less than 1 more than 0 and y less than k and more than 0, and 0 elsewhere. Now we look at question 2a. We are asking to find value of k. In any probability distribution, the total volume under the surface must equal to 1. By setting up a double integral of our function over limits x from 0 to 1 and y from 0 to k and setting that equal to 1, after solve the equation, we get the quadratic equation, which is that k squared plus 4k minus 12 equals to 0. We ignore the negative 6 since the range cannot be negative. The answer for this question is k equals to 2. We move to question 2b. Find the marginal density function of x and y. To find fx, we need to integrate out of y from 0 to 2. When we perform integration, we treat x as a constant, then we will get 2x squared plus 2 over 3x. As for fy, we need to integrate out x from 0 to 1 and treat y as a constant. The answer is 1 over 3 plus y over 6. Then we put back to the function that stated in the answer. As for the question C, we need to determine whether x and y is independent or not. Variables are only independent if the marginal density function of fx and fy from question B equals to the origin joint function. The equation will be 2x squared plus 2 over 3x times 1 over 3 plus y over 6. Then we will get 2 over 3x squared plus 1 over 3x squared y plus 2 over 9x plus 1 over 9y. From the answer, we know that x and y are dependent. Last but not least, the question D asks to find the mean and variance of P equals to 6x minus 3y plus 4, where x and y are continuous random variables with known probability density functions. Using the linearity property of expectations, we will get EP equals to 6ex minus 3ey plus 4. So now we need to determine EX and EY first. To find EX, we need to calculate using EX equals to integrate x times with 3 fx dx. We know that fx equals to 2x squared plus 2 over 3x with the limit 0 to 1. Then we integrate it and times with x. Then we will get expected value of x equal to 13 over 18. Now, same goes to EY. We need to integrate y times with function of fy dy. We know that fy equals to 1 over 3 plus y over 6 with the limit 0 to 2. Then we integrate it and time with y. We will get expected value of y equals to 10 over y. Since we have already know the EX and EY, we put back it in the equation, which is that 6 times with 13 over 18 minus with 3 times with 10 over 9 plus with 4. Then we will get mean of P is 5. For the variance, since the variable are dependent, we need to include covariance. The equation for variance P is 66 Vx minus 9 Vy minus 36 covariance Vxy. First step, we need to find Vx. We need to find Ex squared since the equation for Vx has Ex squared. After integrate, we get 73 over 1620 as the answer. After that, we need to repeat the same step to find Vy and we will get the answer 26 over 81. The third step is to find covariance xy. The equation for covariance is Exy minus Ex times Ey. To find expected value of xy, we use joint probability density function fxy. We need to use double integration, which is x from 0 to 1 and y from 0 to 2. For the first integration, we need to multiply the function of xy, treating y as a constant, and then we integrate the remaining expressions with repeat with respect to y. After simplify the fraction, we get 43 over 54 as the answer. After that, we can plug in the value and the answer is negative 1 over 162. And finally, we can find variance of P. We need to plug in the value to 36Vx minus 9Vy minus 36 covariance xy. And we will get 71 over 15 as the variance of P.